Good day everyone, especially to my dearest electronics students. I am Reymark Teves and I will be your teacher in your major subject in digital electronics. Okay class, I hope that everyone is already here in our class. But before we proceed in our discussion, let's answer these questions first, enable for us to know your initial knowledge about the topic that we are about to discuss. But before that, I will send you the link and you have 2 minutes to answer it. Okay, finish, time's up. As we can see, many of you got the correct answers. The OR gate, NAND gate, NOT gate, and also the NOR gate is almost correct. So for now on, let's start the discussion. Our topic is all about what? Who have an idea about the topic based on the pretest that you have answered? Yes, Mr. Samuel? Okay, very good. The logic gates. Our topic is all about the 3 basic logic gates. But before that, let's have our objective for this lesson. Please read, Miss Angela. Okay, thank you. Discuss the characteristics of different logic gates. The next one, Mr. Zeljan. Okay, thank you. Assemble logic circuit using the different logic ICs. And the third one is perform laboratory activities using logic gates. As our discussion go through, we are expecting that we met these objectives. But for now on, let's talk about the digital logic or the logic gates. Digital logic is the foundation not only in computing, but also many other electronic devices and control systems found in almost every part of our modern life. This said that digital logic or logic gates is not only in computing, but also, or instead, it is very important and useful as part of our different appliances, gadgets that we are using in our everyday life. According to this definition, my question is, what specific things we can use when we apply logic gates in this modern life? Can you give one, Miss Danica? Okay, thank you. Smartphones. Next, Mr. Joven. Tablets. Okay, and the memory devices. Aside from that, also the alarms and buzzers. In logic gates, we have 2 numbers. Also 2 numbers that we can mostly see. These are the 0 and 1. In terms of 0, it is same as high, true, and or on. And the 0, it is low, false, or sometimes it is called as off. The next one, the first one is the AND gate. In AND gate, it performs logical multiplication. If all of the input are high, then the output is high. If any of the inputs are low, then the output is low. For better understand, let's see its symbol and the truth table. As we can see a big shape like letter D, and it has 2 input, input A and input B, represented by 2 straight lines, and 1 output represented by 1 only straight line. In truth table, we can see the input A, input B, and the output. For now on, let's assume that the voltage go through this AND gate. And as the process begin, as we go back earlier, the definition of AND gate is it performs the logical multiplication. The voltage represented by 0 and the voltage represented also 0 will become the output 0. The input 0, then the output 1 has the output 0. The input 1 and the input 0 has the output 0. And the input 1 and input 1 has the output of 1. Because as we said, it is multiplied. When you multiply 0 and 0, it will become 0. And 0 times 1 equals 0. 1 times 0 equals 0. And 1 times 1 equals 1. The next one is the OR gates. It performs logical addition. If any of the input are high, then the output is high. If all the input are low, then the output is low. When we see its symbol, it is likely the arrow shape with two straight line represented by the inputs and one straight line represented by the output. When the voltage go through this orbit, the input 0 and input 0 will become 0. The input 0 and 1 will become 1. The same thing as the 1 and 0 will become also 1. And 1 and 1 will be the output 1. Why? Because OR gate said that it performs logical addition. In logical addition, 0 plus 0 equals 0. 0 plus 1 equals 1. 1 plus 0 equals 1. And 1 plus 1 is not 2. Because as I said earlier, in logic gates, there are two numbers, the 0 and 1 only. In his characteristics, if any of the inputs are high, the inputs is also high. If all of the inputs are low, then the outputs is also low. In NOT gates, it is called the inverter because it performs the inversion. In mathematical logic, it is equivalent to the logical negation operator. When we say negation, it is something similar to opposite, contradict, or contrary. When we see this symbol, it has triangle with a small circle, and it has one straight line in input and only one straight line on the output. Let's assume that the voltage go through to the input of this NOT gate. And as we said, it is the inverter. So it performs inversion. The input 0 will become 1 and the input 1 will become 0 and vice versa. Okay, that's all. Just to make it clear to everyone, it is time for you to ask me if you have any questions in your mind. Anyone have any question, please raise your hand. Nothing? Okay, I am hoping that it is very clear to everyone. Thank you for your active participation in our class discussion. Wait for your assignment and I will send it later. Then we will check it on the next meeting. I hope you learned something from our lesson. Once again, thank you everyone. Have a good day.